Hi, and welcome to part 2 on solving quadratic equations. So in part 1 we looked at solving quadratic equations by factorizing, and in this video we're going to look at, or we're going to begin to look at what happens when you can't easily factorize the quadratic. But before we get into that, I'd like you to pause the video and have a go at these 3 questions. Right, I'm going to go through them now. So you wanna attempt factorizing them. So let's go. We've got x, and then equals 0, and we want to times to make minus 28 and add up to make minus 3. So that's minus 7 and plus 4. So therefore either x minus 7 is 0, right? It could be this bracket that's 0, in which case x would be 7. Or it's this bracket that's 0, in which case x would be minus 4. Okay, so there's your 2 answers for the first one. Well done if you got those. Right, number 2. So we've got 3x and x, and this has to equal 0. So the 3x times the x makes a 3x squared, and then we need to put numbers here that would times to make 2. I guess they've both got to be positive as well, so they can't be minus 1 and minus 2. The reason I know that they've both got to be positive is because we're going to end up with adding up the x's to get positive 7x. So it's either a 2 and a 1, or it's a 1 and a 2, and just by quickly looking, the only way we're going to get plus 7x is if there's a 2 here. So there's 3x times 2 is 6x, plus 1x that you get from here, and that gives you plus 7x. So here we have 3x plus 1 is 0, which would make x be minus a third, or x is minus 2. So well done if you got those 2 answers. Right, number 3. So this is a little bit of a sneaky one because it's actually forcing you to remember that you want to make a quadratic equation, and we can tell that this is a quadratic equation not just because it's within a video to do with quadratic equations, which kind of gives the game away a little bit, but also because you have a look, you see, look, it's only got one unknown in there, x, and the highest power that you can see is a 2. There's no division going on. We could, if we thought about it, we could take everything over to the left-hand side and it would look like a standard quadratic equation. And that is actually what we have to do. We must make a quadratic equation needs to be written equals 0, because then we can factorize it and we can say something about the factor pair. We can't say anything about the factor pair if it equals something else, if it equals 6 or something like that, because there are many options, an infinite number of options, because you could also include all the decimals. As soon as we make it equal 0, we're heavily restricted, right? Because at least one of the brackets would need to be 0. So our first step is to do 2x squared. We take away 5x and we add 3. So we do this to both sides, and the effect that has is, of course, that just moves over there and becomes minus 5x. This just moves over there and becomes plus 3. So that's actually your first step. You need to make sure it equals 0. Now, most of the time, that's already done for you, but sometimes you'll have to do it yourself. So, okay, we're going to try to factorize it. So 2x, x, and then equals 0. And I guess to make minus 5, minus 1 and minus 3. Right, so minus 3 times minus 1 is plus 3. Minus 3x, take away 2x is minus 5x. So we've got 2x minus 3 is 0. Or x minus 1 is 0. So 2x is 3, which makes x be 1.5, or we could just leave it as a fraction, 3 over 2. Or x is 1. There's your 2 answers for that one. Now, just for the next, give yourself a minute to have a go. I'm going to show you, and it's, well, I'm going to say, look, take a minute to have a go, and if you can't do it, I wouldn't blame you, then resume the video after a minute. So here's question 4. So it's, you know, it looks quite similar to these other questions, right? It's a quadratic equation. Pause the video and resume in 1 minute. Right, okay, so hopefully you've established that the difficulty is with this one is we can't factorize it. Right, if I try to factorize it, it's got to times to make 7. So we could either have 1 and 7 or minus 1 and minus 7. And minus 1 and minus 7 adds up to minus 8, not minus 6. Okay, it's not, so perhaps some people may have accidentally done this as a mistake, but it is not this. Okay, that's wrong. Because minus 1 add minus 7, there'd be a minus x and a minus 7x, and altogether there would be a minus 8x. So this is not the way it factorizes. It turns out that it's actually, you know, it's very hard to factorize this. So before I begin to talk about this, let me just kind of go a little bit off. Well, we stay within the same topic, but I'm just going to show you. Right, I'm just going to show you first of all what the graph of y equals x squared minus 6x plus 7 looks like. So this is y equals x squared minus 6x plus 7. And if you have a look, the actual solutions, and if you knew the solutions, right, you could actually work backwards to work out how the factor pair would go. If you think about it, you would be able to do that. These are decimals. They're not nice numbers. They're decimals, they're not nice numbers. And I'm about to turn the screen red to basically as a warning. So you know, it turns out, and it turns out that we could actually have worked this out for ourselves, but we'd need to apply a different strategy first. It turns out that it factorizes, but the way it factorizes is like that. Right? Horrible. How on earth are you supposed to know this? How on earth were you supposed to? Because, you know, it should make you feel grateful. It should make you feel grateful when you have a quadratic that just factorizes with nice numbers, right? Because it's so much easier. How on earth were you supposed to know that it's got a surds in there? It's got a square root of 2, which is a horrible decimal, right? Goes on forever. How on earth were we supposed to establish that this was how it factorized? Right, now if you knew this, say you were given it, you could now actually tell me exactly what the solutions are, because it would either be this was 0, in which case x would have to be 3 plus root 2, which would be this solution here, or it would have to be 3 minus root 2, which would be this solution here. So I'm going to keep the screen red. So the screen is red because I'm trying to illustrate to you that you don't really need to worry about this part, okay? Where exactly this comes from, I'm just kind of trying to highlight to you that it's possible to have a quadratic equation where you get some really horrible answers, and yet still it's, you know, possible to actually get the exact answers. So I'm just going to convince you that if you expand this double bracket, you actually get this. So the screen is still red. The screen is still red. So if you want to skip past the red part, that's fine. This is just total bonus. This is not something you actually need right now. I'm going to do it anyway because I know there'll be some of you who are interested, you know, and that this has maybe made you feel interested because like it looks kind of weird, doesn't it? So anyway, let's do our grid method. So x, got a minus 3, and we've got a minus root 2. We've got an x, we've got a minus 3, and we've got a positive root 2. So what's the idea? Well, we're going to work out what goes in our grid. We'll simplify, and we're supposed to get this. This is what we're supposed to get. It doesn't look like we will, does it? It looks like we're going to get something horrible, but watch what happens. So we get the x squared. So far so good, right? There's the x squared, okay? We have minus 3x and we have minus 3x. So okay, there's the minus 6x. Minus 3 times minus 3 is positive 9. It's positive 9, so not positive 7. So there is something that's going to happen here, which hopefully will all cancel out and just leave us with, well, I guess what we want left would be minus 2, because if these 5 remaining boxes produce minus 2, then when we add them all up, we'll actually get this answer. So let's see if that's what happens. So here we'll have minus root 2 times x. But down here, I'll have root 2 times x, and these actually cancel out. Right, if I have minus root 2x, it cancels out with plus root 2x. Here I have minus 3 root 2. Minus 3 times the square root of 2 is minus 3 root 2. And here I have minus 3 times minus root 2. Now a minus times a minus is a plus, so this is just 3 root 2. But 3 root 2 and minus 3 root 2, when you add those up, again, they just go to nothing, so they cancel. And root 2 times minus root 2. Well, a minus times a plus is a minus, so it's going to be a minus. And then root 2 times root 2, this is this thing where there's 2 ways to think about it. Some people would like to think of this as being, when you remember about the work you did on surds, this would be the square root of 2 times 2, which is 4. So it's the square root of 4, which is 2. So the answer is minus 2. The other answer, the other way you can get it is by thinking, look, what's the square root of 2 times the square root of 2? It's the square root of 2 getting squared, which just undoes the square root, which gives you 2. Okay, and it's a minus because it was a minus times a plus. And so, okay, look, as if by magic, you've recovered this. Yeah, x squared minus 6x plus 7. So this is how this factorizes. But how on earth are you supposed to get that? How on earth are you supposed to get that? Very difficult, very tricky. And so it's actually not the strategy that we go for. It's not the strategy that we go for. We actually learn a different method for solving quadratic equations. Okay, so the way I want you to think about this is you check and don't spend ages on it. See if you can factorize your quadratic. If you can, then that's the quickest and easiest approach. If you can quickly factorize your quadratic, great, do that, because then you can just read the answers off by doing what we did in the last video. If you cannot factorize your quadratic, because maybe it is too hard, maybe the numbers are too complicated, or maybe it's because it's a horrible one which actually gives you something really weird, then you would then use the method that I'm going to talk about in this video. So anyway, what we'll do, and we'll come back to it, is we're going to rewrite this in a different form. Okay, so at the moment this is the standard form for how you write a quadratic. It's just fully expanded, x squared, the x's, the numbers. If we could factorize it, that would be great. That would be the factored form, and in which case it would be a lot easier. And in fact, I don't know why I'm not showing you this slide now, because I'm actually talking about it. So let me just read this instead. So we're going to take an example quadratic expression, a much easier one than the one we just looked at. The quadratic expression that we're going to look at for this example is x squared plus 6x plus 5. So it's got a few different forms. It's just an expression at the moment. We're not setting it equal to anything. It's not y equals this. We're not setting it equal to 0. We're not doing anything with it other than there it is. It's an expression, no equal signs. There are a few different ways it can be written, and these are called different forms. Okay, so one form is the standard form, which is just the fully expanded form, right? Just the normal one that you first see. You first see this when you get taught about quadratics. There you go. Now we could also factorize this. So we want to times to make 5 and add up to make 6. So this would be 5 and 1. So that's called the factored form. Now some quadratics, it's very difficult to work out this factored form. And some quadratics, you just can't write it in a factored form. It's not possible. And the reason is, well, the reason, I can't really talk about the reason just yet. It's too advanced for where we're up to at the moment, but you will at some point find this out. For now, all I'll say is it won't factorize if it floats above the x-axis. If it doesn't cross the x-axis, then it means it doesn't have any solutions to equal 0, which means we wouldn't have been able to recover it from the factored form, which means the factored form never existed in the first place. But as you can already tell, me even saying that sounds a little bit complicated, so that's why I'm trying to not go into it in too much detail. Okay, so there's another form, and this is the form we're going to talk about today. Okay, it's called the vertex form. This is a bit of a funny word, but it's just what it is. It's called the vertex form. The vertex of the graph, by the way, so if I come back and show you this picture, the vertex of the graph is just the very bottom point. So a quadratic will always have a very bottom point. Or if it's a minus quadratic, so if it was a minus in front of the x squared, it would be upside down and it would have a very top point. Either way, there is some point right at the bottom or some point right at the top where, you know, it was going downhill, now it's going uphill. Or if it was upside down, it would be going uphill and then back to downhill. The vertex is just that point right at the, well, if it's like this, it's right at the bottom. The vertex is also where the line of symmetry for the graph would go through. So parabolas are symmetrical. So the vertex for this graph, we can actually see what it is. It's 3 minus 2. Okay, that's the vertex of this graph. So anyway, that's what that's called. And if I look at x squared plus 6x plus 5, it turns out we could write this in a third way. We got the fully expanded way, we got the fully factorized way. We could also do something called completing the square. Okay, and that's when we've done this, when we've accomplished that, we would have written it in vertex form. Okay, so I'm actually going to explain how to do this. I think I'll avoid in this video talking about why it's called completing the square. I might look at the end to see how long the recording is and then decide then. So if I do talk about it, it will be right at the end of the video. So anyway, here are your steps. So the steps, before I've actually gone through an example, do look a bit confusing, but don't worry about that. You'll see it's not too bad when we actually do it. So let's not worry too much about what the steps say. Let's just follow them with this example here. Okay, so example 1, write x squared plus 6x plus 5, which is what we were just looking at here. So this is this easier one. Write it in vertex form by completing the square. Okay, and we're just going to go through these steps and tick them off as we do them. And obviously I have kind of shortened them down a bit, so you'll need to listen and watch what I do to fully understand what the steps are. Okay, so step 1, ensure that the coefficient of x squared is 1. Now at the moment it's just always going to be the case that this is true for us. Okay, it's a massive extension to be putting a 2 in front of the x squared here and asking that. And when we do get onto that, I'll explain what you do in that situation, because there's a little thing you have to do beforehand. But we're basically always going to have this ticked off already, so don't worry about that. Ensure the coefficient of x squared is 1. Yes, it is, right? It's a 1 in front of the x squared, so tick. Okay, step 2, open a bracket, write x. Okay, so open a bracket, write x. Great. Halve the number of x's, close the bracket, square. Okay. So when I'm talking about the number of x's, I look in the original and I see that there was 6x. So halve that is 3x. So it says halve the number of x's, close the bracket, square. Now, it's very important that you just write plus 3. Close the bracket, square. So where's this 3 come from? It's half of this 6. Plus c. So what do I mean by the plus c? I mean the plus 5 here, so I'm going to write plus 5. And then square the number you wrote and subtract this. So I wrote the number 3 there, so I've got to do 3 squared, which is 9, so I've got to take away 9. So I'm going to write equals, and then I'm going to tidy this up a bit, right? So this is x plus 3 all squared. Take away 9 is minus 4. Right, and it turns out this is the answer. This is the completed the square vertex form. Let's actually just check that we actually get this. So x plus 3 all squared, if I do the grid method, so x plus 3, x and 3, this is x squared, 3x, and 9. So we've got the x squared and we've got the 3x and 3x, that's 6x. We've got 9, which is too much, but thankfully we have to take away 4, right? We actually have to take away 4, so when we take away 4, we get the plus 5, which is what we want, right? So if I do x plus 3 all squared and then take away 4, I get x squared plus 6x plus 9 minus 4 is plus 5, which is what we want. That's what we want. So just to recap what we did, we can pretty much ignore step 1 for now, okay? If the coefficient of x squared is not 1, if it's 2, or if it's minus 1, or if it's 3, or whatever, then the question is too hard for you at the moment, so hopefully you won't be asked a question like that yet. So you just basically tick that one off, that's done. Then what we do is, we open a bracket and write x, and then we put half the number of the original x's in there. Now the reason we actually do that is because when we expand this bracket out, we're going to have a 3x and a 3x, which is what we want. We want 6x altogether, and 3 is half of 6. So whatever this was, we halve it and write it there. Close the bracket, write squared. Then we don't forget about the plus 5, so we write the plus 5. And then the problem is look, this 3 squared pops out, but we don't actually want that, so we need to take it away. And then if we tidy that up, we get the right answer. Okay? So I'm going to do excuse me. I'm going to do another example. Oh, by the way, there you go. So the vertex form is where you've completed the square, so there you go. So each of these 3 things here are the same thing. They're all equivalent. They're all the same thing. They're just written differently. So example 2. So you might want to pause the video and have a go and check to see if you get the same thing I do, or if you think you would really value just watching me do this for another example, then just keep watching, okay? Right, the coefficient of x squared is 1, great. Right, I'm going to open a bracket, write x, half of 4 is 2. Close the bracket, squared. Don't forget about the minus 12, and then whatever this was, I square it and take it away, so take away 4. So this is x plus 2 all squared, take away 16, and then that's the answer. Done. Let's just check we get the right answer. X squared plus 4x plus 4, when I take away 16, gives me the minus 12, so it works. Another example. It's trickier because there's a 5 here, and you'll see why in a second. Why is this trickier? I'm going to tell you the best approach for this particular method here is to keep things written as fractions. Do not introduce decimals. Do not introduce decimals. So let me show you what I mean. I'm gonna say, okay, the coefficient of x squared is 1, yeah, good. And then open the bracket, write x. And then what's half of 5? Well, as a fraction, I'm just gonna write it like this. It's half of 5. and then close the bracket, write squared. So I open the bracket and wrote x, I halve this number here, I close the bracket and squared it, yes. I can't forget about the plus c, this is plus 8 that goes there. And square the number you wrote and subtract this. So what's 5 over 2 all squared? So this is why it's a lot easier to leave it as a fraction, because I can just square the top and square the bottom. So this is minus 25 over 4. Right, just a reminder, when you square a fraction, it's just the square of the top over the square of the bottom. And then this bit here, that's kind of already done. I'll want to write 8 as something over 4 so that I've got a common denominator. And so I'm just going to do 8 times 4 to work out what needs to go on the top. So 8 times 4 is 32. So 32 over 4 minus 25 over 4. And this is now going to help me with my final answer. X plus 5 over 2. All squared, 32 quarters, take away 25 quarters is 7 quarters. And there you go, that's your answer. So there's going to be a Heggerty task set for you that just asks you to complete the square. Okay? And that's actually all I want you to be able to do right now. I'm going to show you now, but I won't ask you any questions about it yet. I'm going to show you how this helps us to solve that really tricky, awful question 4. And I'm even going to show you where these horrible numbers come from. So what you want to do is you want to establish, okay, I can't factorize it. So the next thing to try is completing the square. Watch what happens. Open a bracket, write x. Half of minus 6 is minus 3. Close the bracket, square it. Don't forget about the plus 7. What's minus 3 squared? That's 9, so I've got to take away 9. Okay, so I can tidy this up a bit. And we get an equation that looks like this. So it's actually the same equation. It's just written differently. And it's written in a format that we can now solve. You might be able to see, where does the square root of 2 come from? You remember how the square root of 2 kind of made an appearance? And 3 made an appearance? 3 and 2, and we're going to end up square rooting. Okay, so I'm going to add 2 to both sides. X minus 3 all squared is 2. So I just add 2 to both sides. I square root now. So this is x minus 3 is the square root of 2. But remember, the square root of 2 is just one possible thing that would square to make this. I could also have the minus square root of 2. So I'm going to put plus or minus root 2 there. This is like when I did, so a much easier example is just something like x squared equals 25. So x is 5, because when you square 5 you get 25, but x could also have been minus 5, right? Because when you do minus 5 and you square it, you get 25. So this is why I've got a plus or minus symbol, and it's the same reason that that's there. Okay, and then I'm actually in a really straightforward scenario now, because I just add 3 to both sides, and it's quite typical to put it at the front. So the minus 3 comes over there as our plus 3. So it's 3 plus or minus the square root of 2. So one solution is x is 3 plus root 2. And the other solution is x is 3. So I've just literally read it off. 3 plus root 2 or 3 minus root 2. And can you believe it? That's the same as what you would have had here. After you make sure you take into account that if this is 0, then x would have been 3 plus root 2, and if this was 0, then x would have been 3 minus root 2, which are your two solutions. Okay, so I'm going to set you some Heggerty just on completing the square. Not doing any solving just yet, because you need to be able to complete the square consistently and confidently before we can begin doing this, together as a class. Yeah, And here's the little bit of bonus, that I was promising. Because how long's the video? Well, the video's nearly half an hour. Okay, I'm going to talk about it another time because I don't want it to be too long. Right, see you later, guys. Bye bye.